Most of you have probably discussed a few common themes. You want to shout out a few? What are some of the elements that you thought were important in randomization?
In making it effective?
No, sorry, like just in general, like when we talk about randomization, what's the kind of thing that comes to mind? Why do we do it? Maybe the question wasn't entirely clear, but why do we do it? And what's an important aspect of randomizing?
I guess to avoid biases in selection.
Okay.
Selection bias.
Yeah, all right. Any other thoughts?
To attribute causality.
Causality, okay. Yep. Any other thoughts? All right, so basically, I think you mentioned two of the very important ones. Obviously, these are the ones that often come up. I'm going to step one moment, from one moment back and kind of tell you a little bit about this theory behind why we randomize, and it brings up exactly those points. So imagine you're in a population of people that you want to randomize, that you would like to test something in. And in this particular case, you can see I made those people look a little bit different from the population before, because there might be differences. There may be differences between people in terms of are they male or female, right? So gender might be a difference. They may be different in the kind of hair they have, which may be extremely important for your particular trial, or not at all, but those differences exist. And other differences might be not something you can spot. They may not be gender or hairstyle, but they may be things that they believe in. So what political affiliation do they have? How much money do they have? Not everyone's going to tell you that. So these are the kind of things that are hard to observe. We call them unobservables. And the reason why we randomize is because even though we could try and put people into certain buckets by the things that we can observe, we will never be able to perfectly place people left and right and balance them out on unobservables. But when we randomize, we get them into two different groups, and we can basically look at the control and the treatment group and then ask ourselves, according to these different types of unobservables or observables, are they particularly different, or are they on average about the same? So randomization will do in large populations, what it will do is it will average out the number of people that are in the observables and unobservables on average the same in those two groups. By the way, I'm using 500, hundreds, and so forth in here. These are the number of people, these are the kind of numbers I would like you to think about. The number of people on the screen is probably not a representative, a good example of what kind of population you want to randomize. And the reason for that, we're going to come back to later, because small samples are very difficult to deal with, statistically and for your randomization. So I didn't have time to make 500 of these, so I stopped at about 10. But the rest is your imagination. I made really nice little, moving parts in here, because the new PowerPoint has a really good, cool function called the morph between different slides. You should definitely check it out, and then don't use it on an old computer like that, because apparently it doesn't work. It just looks really boring. But imagine that things move around magically and it makes it look a lot prettier. So, important elements of randomization. A few of them came up. You want to avoid self-selection. The reason you want to avoid self-selection is if you go back here, if you allowed people to choose which kind of treatment they would like to receive, maybe Republicans and Democrats would differ along those lines. In fact, actually, there's good evidence to suggest that especially political affiliation can suggest something about conservative people are to certain new approaches, and so you might actually end up with some people opting into your treatment, and then you can say very little about causality. So that's one of them. The second thing is you want to have a randomization mechanism that's applied to the hypothesis. This is a bit more subtle, which is, yes, you don't want people who you're randomizing to choose which side and which bucket they're going into. But you also don't want you as the experimenter to think about which kinds of people you want to place where. And we're going to come to that back in a second, but that's important too. As the researcher, you shouldn't actively make that choice. In fact, when you came in earlier today, I don't know if you noticed, I wasn't the one standing there randomizing you. I asked Laura to do it, and I gave her lists and asked her to read it from left to right. Because I didn't want to be that person doing this and then maybe deciding on the spot to do something different. Because maybe I have an incentive to think that I would like some people who are behaving a certain way to be in the treatment and other people into the control. Another important element of randomization is the independence of observations. And that's also something that often people forget. when they think about randomizing. It's the first thing is that they think about individuals being randomized left and right. But an element we're going to talk about today is spillover, and how that can actually affect your kind of causality estimates you can make from randomizing. With that in mind, I would like to get your views on, are these kinds of assortment mechanisms random or not random? So for instance, if I were to create two groups of people and I use people's date of birth to randomize them, do you think that would count as randomization or not randomization?
Their year or their day?
Let's say month and year.
Well, because, I mean, year is related to a lot of health things.
Okay.
So,
Yeah, maybe not. But if I'm, for instance, saying, okay, let's say it's just month. Just month.
You made a choice at that moment as a researcher, no?
Okay, that would be.
Based on month.
But I wouldn't make it a choice afterwards anymore. So let's say I go in with the plan that everyone born in January goes into my treatment group, and everyone born in February goes into my control group, and so forth.
I mean, date of birth, like when people enter school, affects like their performance, which can have cascading effects for if they think they're smart or not smart, or all kinds of other things.
Yeah, so that's a nice example, exactly. So in theory, there's actually nothing wrong with thinking about the fact that maybe there's some random variation. Children didn't choose to be born in January or February or in the summer months. Maybe parents sometimes do, which is one question you might want to ask, but certainly for things like schooling, it's actually been shown that if you were to do this, you might actually end up pulling some students into your treatment group who do better when you try to increase their GPA, and they do better only because they are slightly older. So it turns out that actually makes quite a difference, and that cutoff can make a big difference in a child's life, whether they are some of the oldest students in the class or the youngest ones. Okay, so that's maybe not entirely the best. What about day of enrollment or signing up? So say, for instance, people come in and sign up for a study that you run.
No, that can indicate motivation.
Motivation, that's another good reason, that's right. So that makes sense as well, right? Like people early in the week have that motivation. What about internal record numbers? Maybe just use the last digit. Is it like an odd number or an even number? And then you assign them to treatment or control.
Are we assuming the internal record numbers are not assigned for any particular reason?
That's, I guess, a good question to ask, yeah. So that is maybe the thing you should ask yourself. Where is that internal record number coming from? Because sometimes internal record numbers in hospitals or other places are just increasing numbers, right? From like the number of people that have entered today, starting with 1, going up to several hundred. But sometimes they have just certain length, like 10 digits, and they're always randomly assigned. And that might be something you could use then, yeah. But without that knowledge, you have to be careful again. You can't trust that an organization does this for you. Alternating, first person, second person.
What do you mean by that?
Oh, sorry, yeah. First person to come into the door, for instance. If you came into the room today and you're the first person to come in, I say, go left, your treatment, and say, you come in, second person, you go to the right. And then the third person goes left, fourth person goes right. What do you think? Does that count, or is that?
How about if they come in groups of friends?
Mm-hmm. That
You
would
did
definitely be a
that,
problem.
right?
So I would have to split up the friends. So, the first person goes to the left again, and the group of friends will be split up. That actually would be a good thing, right?
Yeah, but if it's just two groups,
Yeah.
half of the friends are gonna go together.
Can you explain it again? So
If
yeah.
4 people come,
Yeah,
2 and 2 are gonna be in the same.
that's true.
Yeah.
And do you think that would be a problem, or do you think that's a good thing?
It depends on it's not randomized too much.
Okay.
Because there is a connection between the.
Potentially, that's
Yeah.
right. Yeah.
Oh, the same argument about the motivation. Probably the person who arrived the last one is probably less interested. So.
Potentially,
Just saying
it
potentially.
could still be, but the question is the last person an extreme outlier and is going to pull down the average of the control or the treatment? So it's a good point, but we would maybe only have to worry about that very last person to come in, because the second to last person is in the other group, right? So if they are close in how motivated they are, maybe it's not too much of a problem. So this one is difficult. Lots of people do it, and there may be reasons why you sometimes want to do it. In fact, if you use Qualtrics, the software we're going to talk about today to run experiments online, they actually do a similar kind of process. It's not deterministic in the way that we just talked about it, but they balance it out. So there are theoretical reasons why you may not want to do this, but I'm just bringing it up here because it happens in reality a lot. This one is actually not the worst thing you can do, but there are better ways of doing it. In fact, this is called quasi-randomized. Quasi-randomized is really good already, but it's not considered full randomization. Okay, so what is full randomization? Well, I think it's up to you now to actually try it out. If you pull out your computers, I'm going to tell you what your goal is, what approximately the steps are. You're going to play around with it, and afterwards we're going to go through it together with a few screenshots. And to give you an idea of what I meant, like what the true way of randomizing is, think about it this way. After you clean the data, which you don't have to spend too much time on because we don't want you guys to like sit around and just delete observations for now, but after you do that, normally you generate a number for each observation, and that number needs to be a random number for each observation. Following that, you sort by those random numbers. So there's a random number that's generated for the observations that you have. Then you sort by those random numbers, and only then half of those are control and the other half are treatment. If you know how to do this in Excel, that's great. If not, then we can talk about it afterwards. If you're really good at understanding randomization, I would recommend you don't use the randomization function in Excel, but you use one online and generate a list online. If you have more questions, then let me know, but do get started now. And if you just came in, just grab a seat and then I'll bring you some specific about people that you want to randomize, that you would like to test something in. And in this particular case, you can see I made those people look a little bit different from the population before because there might be differences. There may be differences between people in terms of, like, just in general, like when we talk about randomization, what's the kind of thing that comes to mind? Why do we do it? Maybe the question wasn't entirely clear, but why do we do it? And what's an important aspect of randomizing?
I guess to avoid.
But basically, I think you mentioned two of the very important ones. Obviously, these are the ones that often come up. I'm going to step one moment, from one moment back and kind of tell you a little bit about this theory behind why we randomize, and it brings up exactly those points. So imagine you're in a population.
Biases in selection.
Okay.
Selection bias.
Yeah. All right. Any other thoughts?
To attribute causality.
Causality. Okay. Yeah. Any other thoughts? All right. So. Most of you have probably discussed a few common themes. You want to shout out a few? What are some of the elements that you thought were important in randomization?
In making it effective?
No, sorry.